Polynomial division. So we're going to be doing two types of polynomial division. Long division, which always works. Synthetic division, which is kind of a shortcut, but the problem is you can't always use it. So everybody teaches, you're going to learn the synthetic because it's easier, but you're going to learn the long one because sometimes synthetic doesn't work. And over on the side here, we're going to do this in a minute. I better write that smaller. Synthetic or polynomial long division very closely tracks along with numeric long division. So I'm going to use this to kind of walk through the procedure. So let's look at our first one. Suppose you have x to the third, 7x squared, and I want to divide it by x minus 2. Well, that looks pretty weird. So let's cut over to here and remember how we do this. We go, how many times does this go into here? And we'd say once. Now the way that feels over here is I go, this times what would give me x cubed? And the answer is x squared. So I'm going to write x squared up top because x times x squared is x cubed. I'm kind of ignoring that minus 2 for now. It'll come into play in a minute. Okay, what do I do over here? 5 goes into 6 once. Then, excuse me, I multiply, and that would be positive 5, but I got to subtract that. Everybody knows you got to subtract. The minus isn't there. You got to put it in. So we're going to do that. 6 minus 5 is 1. And then what do? I carry down the next term, and I'll start all over again. So I'd go 5 goes into 10. How many times? 2. I would multiply 2 times 5. There's no minus, but I know I got to subtract them. And then I'd pull down my next digit. And I go 5 goes into 3. How many times? No times. So that'd be 0. And this, I got to subtract, although it doesn't really matter for 0. So this is going to be 3. And I pull down my last term. And I go 5 goes into 30. How many times? 6. And I multiply. I have to remember to subtract. And this would be my remainder. Well, what's that look like over here? X times what is x cubed? Answer x squared. So I put it up there. Then what do? Well, what did I do here? Didn't I multiply this by this? So I got to multiply this by, and now I'm going to multiply it by all of it. I'm not going to forget that there's a 2 there. So this is going to be x cubed. Let me use black. X cubed minus 2x squared. And then I have to switch the signs. That, people mess up on that. Why do I got to switch the signs? Same reason why I got to subtract. There was no minus. We just had to do it. We have to switch the signs because that is the procedure. And what should happen is the first term should always drop out. And here you just add what you see. And that would be minus 5x squared. And that would be like getting this right here. So then what did I do? I pull down the next digit. Here I'm going to pull down the next term. And then I start it all over again. I go 5 goes into there how many times? I got to start all over. So I go x times what equals this minus 5x. And then I have to multiply minus 5x times both of those. Plus 10x. And then I have to switch the signs. Why do I got to switch the signs? Same reason I switched that sign. So this becomes plus, and this becomes minus, and I add what I see. The first term should drop out, and this is going to be 3x. And then I pull down my last term, and I start all over again. X times what is 3x? Plus 3. Then I multiply. Then I switch the signs. I add what I see. And this is my remainder. So these are very close. Instead of doing multiple examples, since it's on video, you can rewind it and watch it again. And you want to watch how closely this tracks what the numbers and the polynomials look like. But now that we have an answer, I want to show you how you need to write your answer. So let's say you do this correctly, and this is a test, so you got to write your answer. This is the answer to the problem. And now you have to do the remainder term. Now this is usually new for people. So this is an understood positive, right? That's positive 9. So for the remainder term, I have plus, and I take this, that goes in the numerator, and whatever you're dividing by goes in the denominator. I know that's weird, that takes some getting used to, but that's how you write the remainder term. The remainder goes in the numerator, and what you're dividing by goes in the denominator. And then this would be my full credit final answer. All right, let's try that again. Now this gets very repetitive. It's weird at first, but this should get very repetitive. Let's do x cubed minus 3x plus 10 divided by x minus 2. Now, I'm putting it the way your book gives you problems, like homework problems. This has two issues. How do I write it? And there's something you got to be very careful of. You can't leave any gaps. Notice how there is no x squared term. So what we have to do is we have to put a placeholder. This isn't like numbers. This doesn't happen with numbers. But we have to worry about it when we're doing this division. So what I'm going to do is I'm going to write it as a normal long division problem. This goes under here, except I'm missing an x squared. So when it's missing, you can write that as a 0. If you don't do that, you're going to get the wrong answer. So if you're missing a term, if there's something missing in the middle, you have to put the placeholder in. This goes out here. And now I start my process. So I'm not going to use red. I'm just going to use one color. X times what is x cubed? Answer, x squared. Multiply. Switch the signs. This term should always drop out. That gives me 2x squared. Pull down the next term. Start all over. X times what is 2x squared? Multiply. Switch the signs. The first term should always drop out. Pull down the last term. Start all over. X times what is x? 1. Multiply. Switch the signs. And that would be my, when I'm out of terms, this is my remainder. So I have a remainder of positive 12. So now I'm going to pull it all together and give my answer. My answer would be x squared plus 2x plus 1 plus 12 over x minus 2. This goes on top, that goes on bottom. All right, we'll crank this up one more level of difficulty, and then we're going to change tracks and do the shortcut way, synthetic division. Okay. I'm just going to write it in standard form here. Now that looks pretty intimidating. A lot of times people don't like this, but you're going to see it's just a small tweak on what we were just doing. So here we go. I look at the first term only to start, and I say x squared times what is x cubed? Answer, x. Doesn't really matter where you put the x up top. I like to line it up with those terms. Once I get this, I have to distribute it to all of them and write that down here. So x cubed minus x squared plus 8x. Then I gotta switch the signs. First term should always drop out. Add what you see. See how there's 2 terms? See how there's 3 terms? So I have to pull down the next term so that they match. And then I start over again. Question, x squared times what is 3x squared? Answer, positive 3. I'm going to distribute. Now that I have that, I have to distribute. 3x squared is 18x plus 24. Now I have to switch the signs. Minus, plus, minus. Everything drops out, so there's a remainder of 0, and we like that. So our answer is going to be x plus 3. Now I'd ask you to rewrite it separately, not just circle it up here. I want to see that you can pull that out and you know that that's the answer. All right, now synthetic division, you can't do this. This problem can only be done with long division. How do you determine whether you can use synthetic or not? So let me erase here. In order to use synthetic division, which is the shortcut method, you must be dividing by x plus a number or x minus a number. No coefficients here. No squareds. Right, in the last problem we were dividing via x squared. So if I see 3x minus 2, you cannot use synthetic division if there's a number in front of that x. That would be okay. You could use synthetic division if you see this. You could not use it if you saw that. It's got to be just x plus a number or just x minus a number. So let's go back and let's revisit the first 2 examples we did, because those were both divided by x minus 2, and that works. X minus 2, nothing to mess it up. So our first example was x cubed minus 7x squared plus 13x plus 3, and we were dividing by x minus 2. So the whole point of synthetic is we're trying to streamline this. So what I do is I'm going to write this division, and I got to strip away all the x's. So I have 1x cubed minus 7x squared plus 13x plus 3, and put a little gap there so it doesn't look like a regular addition or multiplication problem. Like, space those out a little bit. And this part is a little weird. Instead of writing x minus 2, I just write the number part and I switch the sign. So it takes getting used to. But if I do this, now I'm going to follow the procedure. So you're going to need to see this a couple times. I pull this number up, and then I multiply. I add what I see. I drag that up to the next slot. I multiply. Add what I see. Drag that up to the next slot. Multiply. Add what I see. When I get to the end, that's the remainder. Now, I'm going to say my answer. This is my answer with this remainder, but I got to put the x's back in. One way people mess up is they put x squared, x cubed. But this is always the number, then you walk yourself back as far as you got to go. So this is going to be 1x squared minus 5x plus 3 remainder of 9. So I put plus 9 over x minus 2. And if you go back and look at the answer when we did it with long division, it should be exactly that answer. It's just a different way to get it. A lot more streamlined, but a little bit weird. Let's try that second one we did. So that was the second one. Here we go. We're going to do it synthetically. So I have 1x cubed, no x squareds, minus 3x's, plus 10. See, I still got to put that placeholder in. And this has an x minus 2, so I just steal the number part, but I switched the sign. It was minus, so I put plus. There's the setup. Here's the procedure. First step, pull this up to that slot. Pull it diagonally up. That's the first number. Times, add, pull it up. Times, add, pull it up. Times, add, I'm at the end, so that's my remainder. Answer, number x squared, x squared plus 2x plus 1 plus 12 over whatever I was dividing by, which was x minus 2. Now we can't do the next example we did because we're dividing by x squared stuff. So let's try one more we haven't done yet. We'll make it a little bit longer, and then I'll stop and you should try some of the practice problems. Alright, so that one's a little bit longer. This goes under the hood. 1x to the 4th, 11x cubed, 41x squared, 61x plus 30. Divided by x plus 5, so I just steal the number and switch the sign. There's the setup. Now, pull this up, multiply, add, pull it up. Multiply, add, pull it up. Multiply, add, pull it up. Multiply, add, done. 0 remainder. That's nice. We like that. So our answer is up here. I just have to be careful to reinsert the x's. So you should always start at this end. This is the number, the x, the squared, and the cubed. So my answer is going to be x cubed plus 6x squared plus 11x plus 6. Definitely practice those. Maybe rewind this, watch the examples a couple times. Look for other videos if that helps. Excuse me. But definitely practice those problems. Let me know if you have questions. All right, take care.